So we've been looking at finding where a function is increasing and decreasing by using derivatives. So let's just kind of go over really quick what we learned last class period. We looked at what it meant for a function to be increasing, decreasing, or constant. The function f has to be a continuous function on some interval ab and differentiable on the open interval ab. We say that if f prime of c is greater than 0, so the derivative is a positive number for all c's in this interval ab, then we say f is increasing on that closed interval ab. If the derivative f prime of c, so the derivative at x equals c is less than 0 for all c in the open interval ab, then we say that f is decreasing on that closed interval ab. And then the last was if f prime of c, the derivative at c was equal to 0 for all c in ab, then f was a constant. It was a horizontal line on that interval ab. Okay, so that's what it meant to be increasing, decreasing, or constant on some interval for our function. And then we were looking at finding where our function was increasing, decreasing, or constant. And the method that we did that was, first thing that we did was we found the derivative. So first it said, let f be a differentiable function on some interval I. Define the interval on which f is increasing and decreasing. First thing that we do is we find our critical values of f. So the critical values, that is, we find all values c in the interval I where the derivative was equal to 0 or the derivative was not defined, it was undefined. Okay, so we're going to take the derivative, set it equal to 0, find all those values which made it equal to 0, and we're going to look at all the values where that derivative is undefined. Those were our critical numbers. We put those on a number line. So use the critical values to divide I into subintervals. That's how I did it with a number line. And then we picked a point P in each subinterval to find the sign f prime of P. We found that if the derivative was greater than 0 at P, then the function was increasing on that subinterval. And if that derivative at P was less than 0, then we knew that f was decreasing on some subinterval. Okay, so that was a quick review of what we looked at last class period. And we're going to look at a couple more problems with applications. And so using these applications, we'll look again at how to do these. So first example. So we're given that a manufacturer sells video games with the following cost and revenue functions in dollars, where X is the number of games sold, and we're given that X has to be between 0 and 3,300. So we're given that 0 is less than or equal to X, which is less than or equal to 3,300. X equals number of video games sold. And let's see, we're given that the cost function C of X, this is equal to the equation 0.32 X squared minus 0. There's 4 zeros after the decimal and then a 4. So 0.0004 X cubed. So that was our cost function in dollars. Our revenue function, R of X, is given to us, and this is equal to the function 0.848 X squared minus 0. And we have 3 zeros after the decimal, 0.002 X cubed. So we want to determine the intervals on which the profit function is increasing. So we want to know where is the profit function increasing. Well, first of all, we have to find our profit function. Profit, let's call it P of X. Profit P of X, that's equal to how much money we're bringing in, the revenue that we're bringing in, minus all the costs it takes to make that product. And that would give us our profit. And so we need to find our profit function, and we can do that because we're given what our revenue function and our cost function is. So our profit function is R of X. So we're going to look at this function here. So 0. So this is really 848 thousandths is how I would read that decimal. X squared minus, and this would be, what is that? Minus 220 thousandths is how I read that as a decimal. X cubed minus, so we have to be careful here because we're subtracting off this whole function of C of X. We need parentheses around that. So what we did, we can distribute our negative. So this would be 32 hundredths. So 0.032x squared minus 0.00004x cubed. So notice that I can distribute my negative and we can combine like terms first, and then we can go ahead and take the derivative. So our profit function, pull out a calculator. So let's look at this 0.848 minus, because I'm distributing this negative, 0.32. And that would give us 0.528 x squared. If I distribute this negative here to the second term in the parentheses, notice that this is going to change to a plus. So I'm going to have a positive 0.0004, but I have a negative 0.002. So they're opposite signs. I need to take the bigger number. So 0.0002 minus, actually, but I'm going to do subtraction and I'm going to keep the negative. So minus 0.00004. So this would give me negative, because the bigger number was smaller. Opposite signs. So 0.00016 x cubed. Okay, so that's just our profit function. And we want to find where is this increasing? Where is this function increasing? Here, you need to be careful too, because they gave us a domain. They told us our x values are only between 0 and 3,300. So if we find that function is increasing outside of that, where x is negative or x is bigger than 3,300, we're not going to put that in our solution. So first thing we want to do is we want to find the derivative, and then we want to find where that derivative is equal to 0 and undefined. So this we can just use our general power rule. So P prime of X is equal to, so I'm just going to bring my power down front 2, and I'm going to multiply that to my 0.528, and I'll get 1.056 X. I subtract 1 from my power, so it's just an X. Minus, so now I'm going to take my 3, bringing my power down front, which is 3, multiply it to the 0.00016. And I get that is 0.00048. And then I have a subtract 1 from my exponent and x squared. Okay, so looking at this, let me just see a couple of things. I hate that they have decimals in here, but that's okay. We can deal with that. I need to find when is p prime of x equal to 0. And where is it undefined? Well, it's never undefined because this is a polynomial. There's no variables in the denominator. I don't have any radicals I have to worry about or log functions. So we want to find when is this equal to 0. I tend to like to have my higher powers first and decrease in order of powers. So I'm going to put that negative first. So negative 0.00048x squared plus 1.056x equals 0. So I know I can actually get rid of these decimals if I really wanted to. If I multiply both sides of the equation, so let's look at how many places we have to move this decimal over in order to get this to be a whole number. So that would be 1, 2, 3, 4, 5 places. So that would mean I'd have to multiply both sides, and that's the most, by, I need 5 zeros, so 10,000, oops, 100,000. And we don't have to do this. I just prefer not to deal with the decimals if I don't have to. And I don't know if that's going to make my life easier or not, but we can try. So this is going to give me negative 48x squared plus, so I'm needing to move this decimal over 5 places for this other piece, but notice there's only 3 spots. So I'm going to have to add 2 zeros to the end. So we'll get 1, 0, 5, 6, 0, 0. So 105,600x is equal to 0. So we want 2, and I want to see if there's anything in common. I know they at least have a 2 in common, and I noticed that they have an x in common. Let me just see. It's possible that 48 goes into that 105,600. Hey, it does. So let's factor out. Maybe let's factor out a negative 48x. So let's pull out a negative 48x. So if I pull that out of the first term, all we would be left with is a single x. I'm pulling a negative out of a positive, so now we have a minus sign. And 48 goes into 105,600, 2,200 times. And we pulled the single x out, so there's no x left, equals 0. Okay, we got it factored. It's factored set equal to 0, so we can set each factor equal to 0. We're looking at when is negative 48x equal to 0. And we're looking at when is x minus 2,200 equal to 0. Well, negative 48x equals 0 when x is 0. And x minus 2,200 is 0. If I add 2,200 on both sides, I get x is equal to 2,200. Okay, so those are our critical numbers. And I want to test my intervals to see if my derivative in those intervals is going to be a positive or a negative number. So I'm going to plot those on the number line. Remember, we don't have anything less than 0. So I'm not even going to test anything to the left of 0. Then we have this 2,200. And it told us that we couldn't have anything bigger than 3,300. So we want to choose a number between 0 and 2,200. So any number in there. I would probably choose something small and not a fraction. So how about x equals 1? We want to plug this back into the derivative function. So p prime of 1. Here, we really don't care what number we get back. We just care, is it a positive number or a negative number? So you really don't have to figure that value out. You can if you want. But again, we're just curious, is that going to be a positive or a negative number? Let's do it here. So if I plug in 1, I would get 1.056 all times 1. minus 0.00048 all times 1 squared. Well, I notice 1.056 is a bigger number than negative 0.0048. I've missed a 0 on there. So this has to be greater than 0. Since this is greater than 0, then that tells me my function is increasing. So looking at it left to right, it's going up. So I just kind of make that arrow there to tell myself that's increasing. So we just want to make sure that we need to see what's going on between 2,200 and 3,300. My guess is that it is decreasing, but we should make sure. So we want to choose some number that falls in that interval. So maybe let's say X is equal to 2,500. I could have done 2,201 if I wanted, but just something that falls inside that interval. And it can never be a critical number, just to tell you that, so you don't do that. So we want to go in and plug in 2,500 wherever we see an X in our function of the derivative. So we have this 1.056 all times 2,500 minus the 0.00048 all times 2,500, and that quantity is squared. So if we had something like this on the exam, I would definitely let you use a calculator. Technically, you should be able to multiply that out longhand, but that would take too long. So 1.056 times 2,500 is equal to 2,640 minus, I'm going to first square my 2,500. And that result gives me 6,250,000. I'm not going to write that down though. And I'm just going to multiply right now by my negative, or my 0.00048. So that gives me 3,000 when I do that all together. Well, I can figure out what that number is, but I can tell that that number, right, is going to be smaller than 0. So that's really what I'm worried about, positive or negative. Since that's less than 0, that tells me my function is decreasing here. And the question wanted to know when we're trying to find when is our profit increasing. So we are knowing that we're going to want to sell between 0 and 2,200 items to keep our profit in an increasing manner. So profit is increasing. If I wanted it in interval notation, it's 0, parentheses with a 0, and then 2,200. Okay, so let's see if you guys have any questions before we move on. Okay, so there was just a great question about what would have we done if this was increasing after 2,200 also. And my response to the class was that if 2,200 was part of that, was in the domain, then we could just say it's from 0 to 3,300. But there's times where our critical numbers are where it's undefined. So we might have an asymptote there, like in this picture where something is increasing, and then after the asymptote also increasing. In that case, we would not include that value that it was undefined. So we'd have to do, in our case, if it was this way, 0 to 2,200, and then a union 2,200 to 3,300. So great question. So We'll move to one more application problem, and we might see that in this application problem actually. So this is on drug concentration. The following problem says the percent of concentration of a drug in the bloodstream T hours after the drug is administered is given by the following equation. So let me just start with that. Okay, so we're looking at the concentration of the blood in of the drug in the bloodstream. T is equal to number of hours after the drug is taken. K of T, this is going to be equal to the percent of the concentration of the drug in the bloodstream T hours later. And this is equal to 4T, which is in the numerator. And then we're going to put that all over 3T squared plus 27. And it tells us, which makes sense, that T has to be greater than or equal to 0, right? We tested our bloodstream before we took that drug. We hopefully don't have any of that in our system. So A, on what time interval is the concentration of the drug increasing? B, on what interval is it decreasing? So when is the drug concentration increasing and decreasing in the bloodstream? Okay, so if I look at this function, I have to be careful. I can't have any values of T, which sets my denominator equal to 0. I notice though, and if you don't see it, you can always set that equal to 0, but I notice that's never going to be 0. But let's just show really quick. So I'm looking at when is 3T squared plus 27 equals 0. I can try to factor that. I can use the quadratic formula. Actually, here I can use the square root method. So that's, I think, is the fastest. Let's subtract 27 on both sides. In this case, it's the fastest. If I divide by 3 on both sides, I get T squared is -9. And notice if I take the square root of both sides, I actually get an imaginary number. I don't get a real number back. Square root plus or minus the square root of -9, which is 3i, plus or minus. So not real. So there's no number which sets the denominator equal to 0. So to find where it's increasing and decreasing, we need to look at the derivative and find out when the derivative is equal to 0. So let's first find the derivative. Okay, so looking at this, I notice I have to apply the quotient rule. So that was the derivative of the numerator. So the derivative of 4T is just 4 times that denominator. So put parentheses around 3T squared plus 27 minus my numerator, which is 4T, times the derivative of this denominator. So derivative of 3T squared, that's 6T. Derivative of 27 is 0. And then we put this whole thing over the denominator quantity squared. 3T squared plus 27 quantity squared. Let's clean it up a little bit. Let's distribute the 4. So distributing our 4 inside the parentheses. So 4 times 3T squared is 12T squared plus 4 times 27, which is 108, minus 4T times 6T, that's 24T squared, all over this denominator, 3t squared plus 27 quantity squared. So let's combine like terms in our numerator. So 12t squared minus 24t squared, that's a negative 12t squared plus 108. All over 3t squared plus 27 quantity squared. So 12 actually goes into 108 evenly. So if we want to, we can factor out a negative 12. If I pull out a negative 12, that would give me t squared minus 12 goes into 108 9 times. So all over the denominator quantity squared. Okay, so we've taken the derivative. We want to find our critical number. So we're looking at when is k prime of t equal to 0 and where is k prime of t undefined, if it is. Well, we actually know that it's defined everywhere because we actually just showed above that 3t squared plus 27 never was equal to 0. So it's defined everywhere. So we don't have to worry about that. Recall when we're Tuesday, I was telling you guys that when we're looking at a rational function, we're looking at when that's equal to 0, we really only have to worry about the numerator, right? Because we can clear our fraction by multiplying both sides by our denominator. Let's just show it real quick. So if I multiply both sides by this 3t squared plus 27 quantity squared, anything times 0 is 0. And the other side, the whole point of that was so that that fraction would go away. So I'm left with my numerator, negative 12, all times t squared minus 9. So that actually factors a little further. That's a difference of squares. So t squared minus 9 is the same thing, and that factors as t minus 3, t plus 3 equal to 0. So we want to know, when is negative 12 equal to 0? When is t minus 3 equal to 0? And when is t plus 3 equal to 0? Well, a number can never equal 0 other than 0. T minus 3 is equal to 0 when t is 3. And t plus 3 equals 0 when t equals negative 3. So here's the case where that negative 3 is not in our domain. Of our original function, right? K of t. It told us before t had to be greater than or equal to 0. So we only have one critical number in here, which is this t equals 3. So we want to see what's happening on the left of t equals 3 and on the right of t equals 3. So let's look at the number line. Okay, so our derivative function, again, we only really care, is it going to be a positive or a negative number when we plug in a value in our interval? So let's choose a number between 0 and 3. So a number between 0 and 3. How about 1? So if I look at k prime of 1, so I'm really, again, wondering, is my numerator going to be positive or negative if I plug in 1? Well, 1 squared minus 9, that's a negative number, times my negative 12. So I can see that my numerator will be positive. Negative times negative is positive. Notice my denominator. Anything I put in there and I square it, it's always going to be positive. So I got positive over positive. That's a number greater than 0. So that tells me that between 0 and 3 hours, the drug concentration is increasing in my bloodstream. My guess is it's less than that after 3, but let's just show it. So let's choose something that's bigger than 3. How about t equals, it should be t, not, I put x over here, but this was really t equals time. So if I plug in 4 squared is 16, 16 minus 9, that's going to be positive times this negative 12 out front. So I can see that my numerator when I plug in 4 is going to be a negative number. And again, the denominator is always positive. So negative divided by a positive, it's a negative number. So this is smaller than 0, which makes sense. After a while, the concentration of the drug in the bloodstream will start decreasing. Okay. So let's look at that. So it's increasing from 0 to 3 hours, and it's decreasing from 3 hours to infinity hours, which really doesn't make too much sense.